Hi everyone. In this video, we're going to learn how to build an external circuit using Tinkercad Arduino. So in the last video, we focused on lighting up this LED right here, our onboard LED that we said was connected to pin 13. Well, in this case, we're actually going to light up an external LED, which is over here in our components list. But to do that, we need to use something called a breadboard. So I'm going to grab this breadboard. I'm going to drop it in the field. Now notice when I run my mouse along this that certain holes are all lighting up. So if I have my mouse on this negative column up top, notice they all turn green. That's telling me, oops, it made a wire for me. That's telling me that all these holes are connected together. So if I were to plug a wire into this row, I could plug a component into this row and have them be connected, have power run through them both. Same thing with this row here. These are all connected together. And in the middle here, all these columns are connected together. And you'll see more how this works when we start building circuits. So I said I wanted to light up an LED, an external LED. So let's scroll up in my components list. Let's grab an LED and we'll drop it in. Now notice you can actually change the color of this and you can change the name. I want to make mine a blue LED. Okay. And now let's try to wire this thing up. So we said pin 13 was connected to the onboard LED, so let's use a different pin. I'm going to use pin 9. Now it does matter when you click pin 9 and you're moving your newly created wire, it does matter which leg you attach your wire to. So notice we have a cathode and we have an anode. A cathode is the leg of the LED that is shorter. It's unbent, if you notice, and it always receives the ground wire, which we haven't quite gotten to yet. The anode, on the other hand, always receives the positive power, or the wire coming from a numbered pin on the board. So I'm going to drop this wire here, and I can actually change the color of this wire. So most positive power wires will appear red. Okay, so I've connected a positive power wire going from pin 9 to the board, and notice that everything in this column, all these holes are connected to each other. So the power is going from the wire into this column and into the anode of my LED. That power will travel through the LED and down into the cathode, but I don't have anything attached to this column yet. I actually need a ground wire, or the wire to complete the circuit. And I'm going to plug that one in over here. So notice it's in the same column as the cathode. And I'm going to change the color to black. So ground wires usually appear black. It's not absolutely necessary that you change the colors, but it will help you keep track of things. Okay, now let's go to my code. So notice I changed some things already. So if you were to start a new Tinkercad, it would automatically set you up with pin 13 like you're blinking the onboard LED. Notice I changed things around a little bit. I actually set a global variable like we talked about in the last video. So I wrote int. I called my variable, actually let's change this to blue LED because this one's blue. And I set it to pin number 9 because that's what I'm plugged into. And then I have to change all of these to blue as well. So my pin mode really didn't change, except I added my global variable instead of that number 13. And so when you get a big long code, having a global variable would be very nice because if you decide to change the pin number, this is the only place where you have to change it. Okay, I'm going to click on code again to get rid of that, and let's try to run the simulation and see what happens. Okay, so it's lighting up, but there's a little message here, and it's not quite showing me it fast enough, but essentially what it's saying is there's so much power coming through these wires and coming into the board that the LED can't quite handle it all. So the LED could actually burst if we don't do something about it. Let's stop the simulation. Luckily, we have another component that can help us out, and that is called a resistor, this guy over here. What a resistor does is it constricts the amount of power that comes into a component. So we know that this LED probably can't handle all of the power coming from our board. So we have to add our resistor. And there are a couple of ways to hook up the resistor. If you look at the Google Doc attached to this assignment, that shows everything happening in these columns. You can also hook the resistor up using these rows here. So let's do that first. So I'm actually going to set my LED off to the side. I'm going to delete my wires for now. So I'm going to take this resistor and I'm going to do something like this. So notice I'm plugging into this top line here and coming into a column. And it wants to know how much resistance we want. So this little symbol here, this guy is called an ohm. Right now it's set to kilo ohms. I want regular ohms and I want to set this to 330. Okay, so this resistor is plugged into this positive line and comes into a column. Now I'm going to take my positive power wire plugged into pin 9, and I'm going to bring it over to this row right here. Remember, they're all connected, so I have power going from the wire into my resistor now. And I'm going to make that red again. Now I'm going to take this LED and drop it in connected to the resistor. And it's kind of hard to see right now, but this, actually I want to move this over a little bit. This anode is plugged into the same column as the leg of the LED. And my cathode is plugged into a different column. So now I can take a ground wire and connect it there and make that black. Okay, so now I have a 330 ohm resistor that is restricting power flow to my LED. I'm going to make this blue again. If it will let me. It won't let me. So I'm just going to start my simulation. Okay, and now my light is blinking. And notice there's no little exclamation point. There's no issue with power anymore. Now I want to try something different. So we have 330 ohms. If we were to try 50 ohms and then start our simulation, see, now this light is brighter and we're getting the little warning again. So the fewer ohms you have attached to this resistor, the brighter your LED will be. For example, if we try 1000 ohms and run our simulation, now our light is much dimmer. Generally, when working with LEDs, we can stick with our 330 ohm resistor, and that makes the light just bright enough. So the other way to hook this up, let's see here, is to take this resistor, and we have a rotate tool over here, and we can actually, oh, I went too far. We can rotate it sideways, and then drop it into these columns. And then we can take our LED and drop it in like so. So remember, our anode should be connected to a leg of the resistor. Take our positive power wire, hook it into one leg of the resistor. So once again, power going through this wire into a leg of the resistor, through the resistor, into the anode of the LED. And now we just need our ground wire going into this leg. So this way looks a little more confusing. It's much easier in person to do it this way when you actually have the board. So you can set this up whatever way you want. And that is how you set up an external circuit with an LED. Our next lesson will work with setting up multiple LED circuits, and we're actually going to make a little stoplight. If you have any questions, you can let me know. You can also refer to the Google Doc attached to this assignment. Your actual assignment is in the assignment description. Make sure you follow the directions carefully.